is Noah Alves, correct? Yeah, Noah's with the National Weather Service in Portland as a meteorologist since December of 2022. He's a graduate of the University of California, Los Angeles with a Bachelor's of Science in Atmospheric and Oceanic Sciences in 2021. This guy's got some, going through some stats here. And University of Wisconsin-Madison, where he got his master's degree in atmospheric science and oceanic sciences in 2022. I want to know how you did both of those 1 year apart from each other.
The master's was a non-thesis.
Oh, okay. It went a lot quicker. Yeah. Okay, and I lost my spot. Okay, internships includes UCLA's NASA JPL program intern at Los Angeles in 2020, U.S. Naval Research Laboratory intern in Monterey, California, 2021. Pathways intern at the National Weather Service Weather Prediction Center in College Park, Maryland, 2022. Noah also specializes in aviation forecasting, public forecasting, marine forecasting, and is radar certified. Drum roll, this is for Jeff Fordron right here. Specializing in tornado, severe thunderstorm, and flash flood warnings, and partnerships in outreach events. Other achievements include National Weather Service Portland Special Act Award in 2023, an individual award for creating the National Weather Service Portland's Watch, Warning, and Advisory Matrix for partners and operational staff, and the NWS Isaac Climate Outreach Award in 2023 for significant improvements in Weather Service Forecast Office Portland IDSS templates, format, methodologies, whew, it's a mouthful, to serve their partners. Ladies and gentlemen, Noah Alves.
Hello? All right. Thank you, Steve, for that introduction. Again, yeah, my name is Noah. Just to clarify, that's an H at the end, not NOAA, like the that I work for. It's funny how many times people at my own work have actually misspelled my name and spelled it NOAA. But thank you so much for having me here. This is my first time attending an Oregon AMS meeting, so I'm honored to be sharing the National Weather Service's winter outlook for 2023 going into 2024, specifically for Oregon and Southwest Washington. So I did take these pictures on the left and right, and then my coworker took that picture in the middle there. So we'll cover briefly what the El Nino Southern Oscillation, or ENSO cycle, is in case you don't know what it is already. We'll then cover our current ENSO status, to give you a hint, we are going into an El Nino, as well as the historical implications El Nino has on our weather here, and then we'll talk about the Climate Prediction Center's outlook for this winter, and then other implications on drought and hydrology. So ENSO is a recurring climate pattern that involves periodic fluctuations in sea surface temperature and the overlying atmosphere across the equatorial Pacific Ocean. And this has the ability to modify the general flow of the atmosphere. And as a result, it can influence local weather conditions here in Hope. So there are three possible ENSO stages. There's ENSO neutral, where sea surface temperatures near the equatorial Pacific are near normal. La Nina is the cool phase, so cooler than normal sea surface temperatures, and then El Nino, which is what we're going into, warmer than normal sea surface temperatures across the equatorial Pacific. These diagrams here represent that, El Nino and La Nina. So ENSO stages, they fluctuate over time. So what we have here is a time series from 1950 to 2023. So on the vertical y-axis, you have sea surface temperature anomaly. The reds represent El Nino, and then the blues represent La Nina. So there are four different categories for El Nino and La Nina. There's weak, moderate, strong, and very strong. So to be considered an El Nino or La Nina at all, so for example, El Nino, you need sea surface temperature anomalies across the equatorial Pacific to be at least 0.5 degrees Celsius above normal. And you're gonna hear me say normal a lot in this presentation. So what is normal? So the NOAA agency defines normal as the long-term average over the last 30 years. So the average between 1991 to 2020. So I just want to clarify right now, because I'll be saying normal a lot, above, below normal in this presentation. So yeah, and so for a strong El Nino, you need at least one anomaly of 1.5 degrees Celsius. So you can see it fluctuates over time, and right now we're getting into that warm phase again. So El Nino is anticipated through this winter with a 75 to 85% chance of a strong El Nino. These are current sea surface temperature anomalies across the equatorial Pacific right now as of October 4th. So a lot of locations seeing at least 1.5 degrees Celsius above normal, so that's the threshold for a strong El Nino. I do want to point out, just because that we may be going into a strong El Nino, that does not guarantee strong global impacts. However, it does increase the odds that some level of impacts may occur in locations that have a history of being affected by NSO. So there's good model agreement for this. So what you see here, all those individual lines with the dots on them, that represents an individual model. And then I did add my own pink solid line there at that 1.5 degrees Celsius threshold for a strong El Nino. So you can see a lot of those models are exceeding that threshold for a strong El Nino during that November to March period. And there's actually good model agreement as well for El Nino continuing through the spring. CPC, Climate Prediction Center, has an 80% chance El Nino continues this spring. So what happens during an El Nino? What happens to the weather pattern? So the Pacific jet stream gets shifted southward. So a lot of the precipitation and moisture, storm tracks tend to go further south towards the southern parts of the United States. So those locations tend to be wetter and cooler than normal, typically from El Nino. Meanwhile, here in the Pacific Northwest, specifically for winter, temperatures trend warmer than normal. However, precipitation has less of a clear trend. So what I'm going to cover now are for specifically strong El Ninos. This is showing what we've seen for winter precipitation trends for previous years with strong El Ninos. So you look here, do we see a unified trend? Not so much. So for example, 1982 to 1983, we had above normal precipitation. So the greens represent above normal precipitation, the browns represent below normal precipitation. And so in other years like 1991 to 92, below normal precipitation across the Pacific Northwest. So there's not a clear, strong precipitation trend when it comes to at least strong El Ninos. And then we take a look at temperature. So reds represent above normal temperatures, and then blues represent below normal temperatures. Here we do see a bit more of a trend. So most of these strong El Nino years, we've seen at least above normal temperatures. However, it's not guaranteed. That's not always the case. So for example, 1965 to 66, 1972 to 73, those years had below normal temperatures throughout the winter. And you see DJF there. If you don't know what DJF means, that's December, January, February. So that's the average over those 3 months. Okay, now what about snowfall? We all know that snowfall brings the biggest impacts on our lives during the winter. So this is a graph created by Brian Bretschneider. He's a climatologist in Alaska. And so what he did was he took the average snowfall anomaly. So anomaly is the difference from the average. The average snowfall anomaly for all of the El Nino years, and what he has plotted here is the median of that. So this is the median, and so I zoomed into the Pacific Northwest on the right-hand side, and we see typically during El Nino years, we trend towards below average snowfall, with the strongest signal over western Oregon and Washington. And then if we look specifically at 2 locations, so Government Camp, if you don't know, that's in the northern Cascades of Oregon, about elevation close to 5,000 feet, and then Portland. During El Nino years, for Government Camp, tend to be actually near average snowfall, but less than you would typically compared to La Nina years. Yeah. And then for Portland, Oregon, during El Nino years, the average snowfall below average, and then also a little bit less than La Nina as well. Keep in mind the y-axis, different snow amounts. Yeah. All right, so let's get into the outlook published by the National Weather Service Climate Prediction Center. So the CPC has likely above normal temperatures for December, January, February, so for this winter. and then equal chances for above normal, near normal, or below normal precipitation. Now, so I'm going to explain a little bit more about these graphs. There are some things about these graphics that may be misleading or cause some misinterpretation. So the first thing I want to note, this is an average over the whole winter. This is an outlook over the whole winter, so December, January, February. You can have temperatures be above normal in December and February, but have below normal temperatures in January. So just because the outlook says likely above normal temperatures this winter, that doesn't mean you're not going to see days where we're below average or cold. So keep that in mind. And then also, the colors here that you see, it does not represent how much above normal or below normal that we'll get. So we could be 1 degree above normal for temperatures or 10 degrees above normal for temperatures. We don't know that. That's not what this outlook is showing. The colors represent probability, so percent chance. So that's another way that this could be misleading by seeing like, oh, those darker colors over the Pacific Northwest, that's gonna mean it's gonna be really warm. Like, no, that's the probability, that's higher probability for that outcome. In the next slide, I do have, I think, an easier way to represent these two outlooks, which you can also get in the Climate Prediction Center website. So I hope you like pi and probability because I have some pie charts here. So what we have here, I have Portland, Oregon on the left-hand side, and then Pendleton, Oregon on the right-hand side. Actually, I do want to note some portions of eastern Washington and northeast Oregon, you can see, lies in that leaning below normal precipitation, which I'm also going to explain because that can be also a bit misleading. So when you see these pie charts, so the top two pie charts are for the temperature outlook this winter, and you see there's about 55 to 60% chance that we'll see above normal temperatures. And then when we say equal chances for above normal, near normal, or below normal precipitation, what does that mean? So across the board, it's around a 33% chance for either above normal, below normal, or near normal. So the thing about Pendleton, so Pendleton lies in that leaning below normal precipitation part of this graphic. But if you look here, there's still only a 35% chance that Pendleton, Oregon is going to be below normal. The reason why they have leaning below normal there is because the contour line for leaning below normal starts at 33%. And they have the probability for below normal above that at 35%. And then there's another way to look at this. There's a 65% chance, approximately, that will be near normal or above normal. So that's another way to look at that. So let that sink in. I hope I didn't confuse you with that, but I tend to think that looking at these pie charts with probability are, I think, a better way of looking at the outlook. So let's look at the current drought monitor right now. So on the left-hand side, current drought conditions over Oregon. This is not an outlook. This is the current conditions. So these colors represent the intensity of the drought. Southeast Oregon's not in a drought right now. We can see during the water year, October 2022 to September 2023, much above normal precipitation in that portion of the state, while in Northwest Oregon, Southwest Washington, we were below normal. So hence the severe drought across the Willamette Valley and extreme drought in portions of Lynn and Lane counties. And then these are just impacts from droughts. I think the main thing here, fire risk increase, river flows are low, reservoirs, lakes are low. So right now about half of Oregon is in at least moderate drought. And then same looking at Washington, Southwest Washington is currently in a moderate drought. We did see below normal precipitation during the water year as well for that location. Extreme drought in Washington, mainly in the North Cascades. And then drought impacts for Washington, similar to Oregon. 72% of Washington right now is in at least a moderate drought, so fire danger increases, river flow may be low. So those are some of these other impacts. And then the Climate Prediction Center also does put out a drought outlook. for this winter. So this is valid for right now until January 31st. So I zoomed in here on the right-hand side. They're calling for drought removal or drought improvement in portions of western Washington and western Oregon, while drought remains or develops in parts of eastern Washington and northern parts and central parts of Oregon. Now, whether or not this El Nino has to play a role in this, maybe. I mean, there's still like a 33-35% chance of a below normal precipitation, so maybe that has a role in it. I mean, but this could also be influenced by climatology as well. You know, in the winter, we tend to get more precipitation in the western parts of Washington and Oregon. So maybe that could be why that they're calling for drought improvement. But we'll have to see this winter how precipitation plays a role. But that's what the Climate Prediction Center has right now for drought. Now, hydrology implications. So what I have here is La Nina and El Nino versus runoff during the water year. So this is the Willamette River at Salem, the Rogue River at Ringgold. I'm gonna apologize if I misspell any of these names. I'm new to this area, so. What we see here, we do see this negative regression line here. It's not a strong correlation, but typically with these El Ninos, we tend to have lower runoff. So Umatilla River at Pendleton and then John Day River at Service Creek. That's the typical trend, but again, that is not guaranteed. There are some years like 1983 where there was above normal runoff, and that was actually a wetter than normal year during that winter, during that El Nino. So that's the trend for hydrology, potentially lower runoff, assuming that you get lower precipitation. So let's summarize all of that. We are currently in an El Nino with a 75 to 85% chance of a strong El Nino through this winter. Historically, strong El Ninos tend to bring warmer than normal temperatures to the Pacific Northwest. However, precipitation trends are less clear. The National Weather Service Climate Prediction Center outlook for the Pacific Northwest in general for winter 2023 to 2024, likely above normal temperatures, so that's a 50 to 60% chance, and equal chances for above, below, or near normal precipitation, each of those outcomes having about a 33% chance of happening. And then potential drought relief in Western Oregon and Washington. I do want to give this disclaimer. Climate predictions can have skill in predicting seasonal totals and averages. However, the most impacts are going to be associated with short duration storm systems. So just because we give you this outlook, don't prepare your whole entire winter off this outlook. There can always be anomalies in the forecast. So that's why we always make sure you stay informed and prepared for anything that could happen. So weather.gov/Portland is where you can find our latest weather forecasts. There are other ways to stay informed. NOAA Weather Radio. Turn on your wireless emergency alerts. Social media, Oregon Alert. If you're on the coast, if there's a tsunami, there's that. And then the Weather Ready Nation Ambassador Program. I'm gonna plug this program. This is a program with the National Weather Service. If you have an organization or company or school that you're a part of, you can partner with us at the National Weather Service. At the National Weather Service, there's only so much we can do when it comes to outreach to all of our communities. There's only so much we can do. But if you want to partner with us, it's a free program, easy to sign up for, low commitment. As an ambassador, you help share messages on how to prepare for impactful weather. You share our social media posts, social media graphics that we may have. You just be a liaison between us and your colleagues and your friends and family for how to prepare for impactful weather. Because we can talk about climate and weather all we want, but if we don't know how to prepare for it, like what's the point? And this also helps because this can help us outreach to potentially low-income or underserved communities as well. We have one of our Weather Ready Nation ambassadors, the Cooper Mountain Vineyards. They're a winery. They actually helped us with changing our frost freeze criteria because our old criteria apparently was not doing it, was not preparing them enough for potential freeze and impacts. So, and now we changed our criteria for frost freeze because of them. So that's one way that a company like that or organization can have an influence. So I just want to say thank you again so much for having me here. This is our public email and phone number if you want to call us. Facebook, Twitter, or X, we're on there. Trina Jensen is my supervisor for all these outreach events, so more specific questions you can ask her. That's her email, or you can ask me during the Q&A or after this meeting. So thank you so much, everyone.